Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. This is the 6th episode in my series to find an effective and efficient mapping from my MacBook keyboard to the various Vice emulators. Last time, we got past a blocker caused by the Mac's Option key and have the top 4 of 6 rows of the Mac keyboard mapped. It's the home stretch, the last 2 rows to map. We'll start with the 5th row. The first key is the left Shift key. Checking the flags, we see flag 2. Look at that, a flag to indicate the left Shift key. So the left Shift key is mapped. Well, almost. In prior episodes, we'd encountered cases where a key mapping had inadvertently sent a Shift and Commodore key press at the same time. Because of this, although we use the Mac's Control key to act like the Commodore key, we do not actually map it as such, which would require flag 8192. But we still need a way to do this character set swap. We can do this by adding another definition to the left Shift key, and that means adding the 32 flag, giving a Shift flags of 34, and then adding a Control variant for that key. But what are the Shift flags for this mapping? We need the Control key on the host Mac, or flag 1024, and the Commodore key on the emulator, or flag 2048, and also the Shift key on the emulator, or flag 1. That's a value of 3073. And that mapping does the trick, intentionally causing the Commodore and Shift keys to be sent at the same time and forcing the character set change we fought to eliminate with earlier mappings. As we can see. The next part of the line are the letters, and we know how to do this now. 3 mappings per letter. The letter itself, but indicating another mapping with the 32 flag. The Control letter mapping to get the Commodore letter Petsky character on Vice, using the combination of 1024, or Control key is pressed on host, and 2048, or Commodore key is combined on emulator, for a total of 3072. And the shifted letter mapping, using a capital letter as the key code, and a 1 flag to make sure it is shifted on the Commodore. And then we repeat this for the rest of the letters in the row. X, C, V, B, N, and M. The remaining symbols on the row are simple to map as well, needing only to map the base and shifted version of each, comma and less than, period and greater than, slash with question mark. That leaves the right shift, which is similar to left shift, but needs a different flag, 4 this time to indicate the right Shift key, and to handle the character set switch, we'll need to add that 32 flag, then map the Shift and the Control Shift sequence. With that, the 5th row is done. The bottom row of the MacBook doesn't have very much to map. First of all, the FN key, meaning function, isn't mappable at all. We've already mapped the Control key, treating it as the Commodore key, but not actually telling Vice that it is. The Option key has been mapped to the 64's Control key, using the 16384 flag. I'd also already mapped the left command key to act as a standalone Commodore key, using the 8192 flag. If you really needed to send a key press of the Commodore key by itself to Vice, you can use this mapping. The right command key will remain unmapped, and the right Option key will end up acting like the Control key for any combined key presses. It is as straightforward as it can be. And now the cursor keys, which on the Commodore 64 were terrible. The Mac has a much better setup for cursor keys, and we can map them to work in the emulator. Left maps to Shift cursor right, which is actually cursor left. Similarly, up maps to Shift cursor down on the 64, meaning cursor up, down to cursor down, and right to cursor right. And the keyboard is fully mapped, except the Commodore 64 has a few more keys that do special things when combined with Control. Most of these are simply duplicates of Action keys, but there are a few that are unique and a few others that are worth mapping just because. It turns out that the Commodore 128 System Guide has an excellent table listing all of the possible control codes, along with key mappings for those that have them, and whether those mappings work on the C64 or the C128 or both. The following combinations are possible. Control-C acts like stop. Control-E sets the text color to white, same as Control-2. Control-H disables the ability to toggle the character set using the Shift Commodore key pair, which, as we've seen, can be pretty useful. We'll want to remember that one. Control-I re-enables character set swapping, another useful code. Control J is supposed to provide a carriage return, though in testing I found it didn't do anything. Control M is the same as the return key. Control N switches the Commodore 64 to the lowercase uppercase character set. That's new. Control Q is another way of doing cursor down. Control S matches the home key. Control T is the same as delete. Control pound sets the text color to red, which Control 3 can do. Control semicolon works like cursor right. And finally, Control up arrow turns text green, just like Control 6. That leaves 3 new control codes to map. Since these will map to option key sequences, the keyboard debugger tells us that option H is key code above dot, mapped to the H key, with flag value 4096 to indicate the Commodore's control key is pressed. Option I, using key code dead circumflex, maps to Control I, and option N, or key code dead perispomeni, maps to Control N. That finishes the epic of building my Vice keyboard map file. It's almost what I had originally planned. I just had to move clear from F11, which was unmappable, to Shift F12, and swap the keys I had intended to map for Commodore and Control. I also ended up needing a special standalone Commodore key mapping, and a special mapping to toggle character sets. Finally, I added in a few additional special sequences. My completed VKM file for mapping the MacBook keyboard to the Commodore 64 is available to anyone who wants it. The link is available in the description below. The next episode will be a final summary and a quick guide to VKM creation and editing, and I expect that will be the video with the most general value. For those of you who came along with me on this journey, thank you. Why did I do all this? Well, to be honest, partly to learn video editing and build my process for creating and posting to YouTube. But also my hope was not only to explain how to create or edit Vice keyboard mapping files, but to point out potential traps and explore some of the nature of how keyboards, both modern and retro, work. I also wanted to demonstrate one developer's mindset to tackling a problem like this. When I started, I simply had a goal of making it easier to type in Vice. I didn't know how I was going to do that. I set goals and made a plan because that's how I take on any project. Then I dove in and tried to make that plan reality, and it mostly worked. When it didn't work, I adjusted and refactored as necessary. The VKM file is really a program, written in an arcane and proprietary language whose syntax is not fully documented. It takes the same skills to make Vice keyboard mapping do what you want as it does to program a computer. Or perhaps I've got that reversed. It might be that having programming skills changes the nature of dealing with a configuration file like the VKM. Either way, I got through it and came out the other side knowing something new and interesting, even if only to me. If you enjoyed this, let me know. If not, well, let me know that too. Thanks again for watching.
So much space, need to see it all.